All right, we're going to do about 10 problems today. 5 of them I'll guide you through, and the other 5 you'll try on your own. So hopefully you have a good idea what you're getting into before we get started here. We're going to go over 25 and 26 first, and these are both proportions. Okay, so proportions you solve by cross multiplying. And I want to be able to do this in my head to speed this up. So 5 times x plus 1 is 5x plus 5. Okay, 5 times each of those. When you take x plus 1 times x plus 2, this is going to be x squared plus something x plus something. Okay, we have the 1 and the 2. 1 plus 2 is 3. So they have to add to the number in the middle. And 1 times 2 is 2. And multiply to the number at the end. If you can recognize that pattern, that's going to save you a bunch of heartache. Okay, so when you're multiplying two binomials, just add the numbers to get the number in the middle, and multiply them to get the number at the end. That's only if they both start with a 1, like they do here. A 1 in front of the x and a 1 in front of the x there. So then you can do that. Otherwise, you got to grid it out. It's the same way. If you have a factoring problem like this, you can just do it, because there's a 1 in front of the x squared. If there's a number out here, you have to grid it out. Okay, let's get rid of both of these. I like to do that all at once so you get a 0. I'm going to go ahead and pause this for a minute, let you combine the like terms, and try to find the answer. Okay, so x squared minus 2x minus 3. Numbers that multiply to negative 3 and add to negative 2 are going to be negative 3 and positive 1. And you get 3 and negative 1. Now, if you look in the back of the book, it only gives the answer 3. It doesn't give the answer negative 1. And up here is why, because negative 1, if you check it in here, it's kind of like those excluded values. If you put 3 into this equation, you'll get, well, 3 plus 1 is 4. So 5 over 4 equals 5 over 4, because 3 plus 2 is 5 and 3 plus 1 is 4. So it equals each other if you put in 3. It works. That's awesome. If you put in negative 1, well, negative 1 plus 1, you're dividing by 0. And you just can't divide by 0. You're not allowed to do it. So this is extraneous. Did I spell that right? Golly. It says check your solutions as well. So this is an extraneous solution, E-X-T-R-A-N-E-O-U-S. N-E-O-U-S. Look in the book for the correct spelling there of extraneous. Okay? Now, let me put it here. E-X-T-R-A extra N-E-O-U-S. It's an extraneous solution. So that one goes away, and you're just left with the 3. These ideas that we have in these sections, they always pop up at later times. It's really important that you keep up and you follow along and you know what you're doing. Okay, let's look at 26. Again, another cross multiplication one. I'm going to let you start this one. Go ahead and try to cross multiply and put your equation in standard form. Make it equal 0. Go ahead. Okay, so let's cross multiply. And I don't have any binomials I'm multiplying here, so this is good. So 4 times c plus 25 is 4c plus 100. C times c plus 4 is c squared plus 4c. Okay, I like my c squared to be positive, so let's get rid of everything over here. Minus 4c minus 100, and look at how I lined that up. I lined up my c squared with other c squareds, which there aren't any. I lined up my fourth c with the other 4c, and I lined up the number that should be at the end with the negative 100. And I get c squared minus 100. This is difference of squares, so we'll do c plus 10 and c minus 10. You can think of this a couple ways. If you notice it's that, the square root of that is c, and the square root of 10 is 100, you can just write plus or minus like that. Or you can say, well, what numbers multiply to a negative 100 and add to 0? Those numbers are 10 and negative 10. That will get you that. So you can think about that either way. And if I look up top, neither of these, the numbers that wouldn't work, negative 4 is an excluded value, and negative 25 is an excluded value, and that's not either of mine. So that's good there. Okay, I'm going to stop this and go to a new video just so this